Lesson 4.7, Arithmetic Sequences. Today we're going to work on explicit formulas. So our goals are to be able to identify and extend patterns and sequences, and to be able to represent arithmetic sequences by using explicit formulas. Given the linear equation y equals 4x minus 5, suppose we substitute the natural numbers 1, 2, 3, and so on in the equation. This yields the following outputs: negative 1, 3, 7. Let me write those out. Negative 1, 3, and 7. This can be considered an arithmetic sequence. If we substitute an n value in for the x and an a sub n for the y, we can rewrite this equation as this yellow box. A sub n equals 4 times n minus 5, with the restrictions that n would have to be a natural number. So what this shows is that we can take any linear equation and turn it into an arithmetic sequence. And specifically today, this is called an explicit formula. So with what we know, anything linear is going to be an arithmetic sequence. So let's look at these equations or sequences and decide if they're going to be arithmetic. Part A, we're cubing and then we're subtracting 6. Part B, multiply by 4, add 7. Part C, multiply by 2/3, subtract 5/3. Part D, multiply by negative 2, add 2/3. So which one of these is not like the other? Yes, you guessed it, part A. We are cubing it, and that is not going to give us an arithmetic sequence. So if I were to make a table of this function in green, if I plug in 1 and cube it, subtract 6. Plug in 2, cube it, subtract 6. I'm getting this list of numbers, and notice there is not a common difference that would fit this sequence. So therefore it is not arithmetic. Explicit formula. Each term is of the form n a sub n, and the first term is the ordered pair 1 a sub 1. The slope is the constant difference, which we call d. So remember our slope formula. Slope is rise over run. So if we're saying the constant difference is the same thing as the slope, let's take the slope of those 2 points. So I'm going to go a sub n minus a sub 1 over n minus 1. If I turn this into d over 1 and treat it as a proportion and cross multiply, I get a sub n minus a sub 1, top times the bottom, equals d times the bottom, d times n minus 1. So now this matches the top step in yellow. And if I want to write the explicit formula, all I have to do is get a sub n by itself, so I'm going to add a sub 1. So this in turn is the formula for explicit sequences. So here's the explicit formula. The nth term of an arithmetic sequence, with the first term being a sub 1 and the constant difference being d, is given by this form. So here's our first term, and this is our common difference. So let's try some examples. Find the 40th term of a sequence. Write an explicit formula for this sequence. So first, let's do our formula. So the form for explicit is a sub n equals a sub 1 plus our common difference times n minus 1. So we have to plug in for our first term, and we have to plug in for our common difference. So copy the mess. Our first term is 100. And our common difference, well, how do we go from the next step? Looks like we're subtracting 3. So this is going to be minus 3. And here's our solution. So up here it asks us to find the 40th term. So our notation is going to be a sub 40. So if I plug that in here, anywhere I see an n, I'm going to plug in a 40. So I have equals 100 minus 3, and then there's where my 40 is going to go. So what's going to happen is we're trying to find our 40th term after this long list of numbers. What we're going to do is we're going to subtract 3 39 times. Because if you look at this, this is our first term, so to get to the 40th term, we have to subtract 39 times and not 40 times. Because the first time that number is already given to us. So if we subtract 39 3 times, our 40th term is going to be 100 minus 117, which is negative 17. So this is different from recursive. In recursive, you had to have the previous number to get the number that you wanted. So in this case, we would have had to have the 39th number, the 38th number, and all of those numbers before to get the answer that we wanted. And see how that would take way too much time. So explicit is the quick way, because we could find the 1,000th term if we wanted to. We could find the 1,000,000th term. But to be in recursive, you have to have that a sub n minus 1, and that means the previous term. So in purple, this would be our recursive formula, where our starting value is 100, and we have to subtract 3 from the previous number. So explicit is a very quick way to find numbers in a sequence. Let's try another one. Write the explicit formula for this sequence. So a sub n equals a sub 1 plus our common difference times n minus 1. So the only things we have to figure out are what is our first term and what is our common difference. So I copy the rest of it. So a sub n equals. The purple, our first term is 20. Our common difference, well, subtract 10, subtract 10, subtract 10. That's going to be a negative 10. And then we just copy the blue part. So this would be our explicit formula for the sequence. Which of the following formulas below is the explicit formula for the following arithmetic sequence? So our form is a sub n equals a sub 1 plus our common difference times n minus 1. So the things we're worried about are what is our common difference and what is our first term. So let's figure out the purple number first. Our first term is negative 5. So I see negative 5, doesn't look like we have, doesn't look like what we have above. So I'm going to throw out C and D. And now I'm looking for my common difference. So I'm going to start here. It looks like we're adding 10, adding 10, adding 10. So part A is going to be our solution. Let's look at a word problem. The number of seats in a given row of a theater is given by the arithmetic sequence a sub n equals 20 plus 2 times the quantity n minus 1. Which row has 80 seats in it? So this question is a little bit different. They're telling us what row has 80 seats in it. So we have to figure out the n value. So here's what it's going to look like. This is our original formula. So we're going to plug in 80 for the a sub n. We're trying to figure out what n is. And now we're solving an equation. So I'm going to subtract 20 And I'm going to distribute in the same step. Get our numbers together. And our last step would be to divide by 2. So the 31st row would have 80 seats in it. So if we look at this, the first row has 20 seats. A sub 1 has 20 seats. A sub 2 is going to have 22 seats, and so on. So we're starting with the sequence 20, 22, and every consecutive row is going to have 2 more seats in it. So we could sit and figure out how do we get to 80, but I think it's a little bit easier to get this into the formula that we want and then figure out the number of seats. Let's do one more. You decide to start a fitness program. You plan to run 1/2 mile on your first day. Then you will add 1/10 of a mile to your workout on each successive day. Write an explicit formula to express how far you will be running on day N. So we're going to do explicit and recursive. So here's how I'm going to organize it. Let's do explicit first, because that's what we're working on today. So the first time we run, we're going to run 1/2 of a mile. And then every day we're going to add 1/10 of a mile. So if I add 1/10 to a half, here's what's going on. I need to get a common denominator, so a half is equivalent to 5/10. So 5/10 and 1/10 make 6/10, which reduces to 3/5. So my next number is 3/5, and so on. And we could keep figuring that out. But I think we have what we need. So we have a sub n equals our first term, which is 1/2 of a mile. And every day we're going to add 1/10. So there's our explicit. For our recursive formula, our first term is still 1/2. The previous term plus our common difference. And this would be for all n greater than or equal to 2. So basically, all you need to know how to find today is the first term and the common difference to be able to do explicit formula. This concludes my lesson.